Space and time are the arena where the events in the universe occur, the basis of all reality. But what if these are not basic elements at all, but stem from something much deeper? A new theory connecting quantum mechanics with gravity puts forward a shocking idea. Space-time arises from quantum entanglement. Yes, that very strange connection between particles that seems to violate all the rules of physics. How can this be possible? If this idea has reshaped your brain, you are in the right place. Subscribe and press the like button. This directly supports our mission to dive deeper. Imagine a web woven from invisible threads. These threads are quantum information. They connect particles, even if they are billions of light years away. If these connections break, space disappears. It simply turns into nothingness. Scientists have already begun to find evidence of this, from the mysterious behaviors of black holes to mathematical models showing that space itself consists of quantum information. What does this mean? Is it possible to control the structure of reality? And most importantly, if space and time are not fundamental, what is real? Let's solve this. Time and space will be as real for us as the air we breathe or the ground beneath our feet. However, modern physics is beginning to paint a completely different picture. More and more data show that space and time are not fundamental entities. Think of a hologram. When you look at it, it looks like a three-dimensional image, but actually it is recorded on a two-dimensional film. What if our space-time is also a hologram, recorded not just on film but in a network of quantum interactions? This idea might sound strange, but the most advanced theories are pushing us in this direction. Let's say you are playing an open-world computer game. Your character can travel, see cities, mountains, and rivers, but in reality, all of these consist of nothing but data in the processor created by the interaction of algorithms. The world inside the game is an illusion. It exists because there is program code supporting it. The same thing applies to our space-time. It might not be more real than a virtual world. And the basis of everything is something else: quantum information. Physicists have for a long time noticed strange clues that space-time behaves not as something fundamental, but as a structure dependent on other factors. For example, quantum fluctuations. When looked at on a very small scale, space looks foamy and unstable. This is strange for something accepted as fundamental. Black holes and the information paradox. According to the theory of general relativity, nothing can escape from a black hole. However, quantum mechanics claims that information cannot be destroyed. Where does this paradox come from? And finally, the holographic principle theory. Calculations show that all information related to what is in a volume of space can be encoded on its boundaries, just like in a hologram. Thus, space and time, which we see as the basis of everything, might be nothing other than a derivative effect of quantum entanglement. If space-time is not fundamental, then perhaps it is controllable. And this is the first step taken toward technologies that seem like magic today. Imagine two twins who can feel each other from a distance by a miracle. One pricks their finger, and the other, thousands of kilometers away, immediately feels the pain. Of course, this is impossible, but particles possessing quantum entanglement behave exactly like this. Quantum entanglement is one of the most mysterious phenomena in nature. If two particles are entangled, regardless of what the distance between them is, their states are instantly connected to each other. If you change the state of one, the other immediately understands this. It is as if, even if there are billions of light years between them, they exist in a single system. In 2015, physicists at Delft University of Technology in the Netherlands performed one of the most accurate and rigorous tests regarding quantum entanglement. They took two diamond crystals and created entangled photons between them. The distance between the crystals was 1.3 kilometers. When they measured the state of one photon, the second one changed instantly, faster than the speed of light could allow for information transfer. This is a truly wonderful discovery. In classical physics, everything occurs in sequence. When you move an object, its effect spreads through space at a speed not exceeding the speed of light. However, entangled particles, ignoring all ordinary laws, seem as if they have agreed beforehand on their states. So how can this be possible? Here is where the strangest part begins. Entangled particles seem to influence each other instantly, but no signal is transmitted between them. Physicists call this the state of quantum non-locality. This is not information transfer in the classical sense, but something more fundamental. A clue regarding the hidden laws of reality that we do not yet understand. Albert Einstein called quantum entanglement spooky action at a distance and refused to believe that nature could work in this way. He assumed that at the basis of the universe, there were hidden variables that allowed us to see quantum entanglement. Although in reality there is no instantaneous interaction, experiments performed in recent decades proved Einstein was wrong. Entanglement is real, and there is no need for hidden variables to explain it. But what if entanglement is not just a strange quantum phenomenon, but the basis of reality? If particles can perceive each other from any distance, could space-time be not an independent thing, but just a result of this global connection? Physicists are seriously considering the hypothesis that without quantum entanglement, space itself could disappear. This idea is related to the ER equals EPR theory, which suggests that space-time is full of tunnels and that quantum entanglement is the same thing as this. If this is true, space is not an arena where events occur, but a dynamic structure created by invisible quantum connections. In this case, space is not primary, but just a side effect of the information connecting particles. This means that if we learn to control entanglement, we can literally change reality. Imagine you are stuck inside a black hole. Light cannot escape. Space bends and time stops. It seems like there is no way out. But what if there is a particle in another place in the universe with quantum entanglement connected to what is inside the black hole? What if this connection is not just a mathematical abstraction, but a tunnel in space-time that could provide you with a way out? This is the idea that physicists Juan Maldacena and Leonard Susskind put forward in 2013. They suggested that ER and EPR, ER represents wormholes, are tunnels connecting 2 points in space. EPR is a strange quantum connection, allowing particles to establish instant communication between them. Their idea is that these two phenomena are actually the same thing. Quantum entanglement is like the building material of wormholes. If ER equals EPR is true, this means that when two particles enter into quantum entanglement, there is actually a small wormhole between them. In daily life, this connection is not noticed. But if it could be expanded somehow, perhaps a real tunnel that could be passed through might emerge. It sounds like science fiction. However, equations show that gravity and quantum mechanics could be connected through entanglement. In this picture, space-time is not something static, but a dynamic network of quantum connections. And the more entanglement there is, the stronger and more stable the structure of reality becomes. But is it possible to create such a wormhole? Right now, this remains only as a scenario. However, in 2022, physicists performed an experiment that could be called the first clue to the artificial creation of the ER equals EPR effect. Scientists at the California Institute of Technology, using Google's Sycamore quantum computer, made a wormhole simulation in a simplified quantum system. They created entangled states that looked mathematically identical to the equations defining a tunnel in spacetime. Of course, this is not yet a real wormhole that can be passed through, but even the fact that entanglement can be interpreted as a micro version of gravity tunnels is already impressive. If ER equals EPR is truly right, gravity is not an independent force but a side effect of quantum entanglement. Spacetime is not fundamental, but forms dynamically like a network of interactions. So can wormholes be controlled? If we learn to control entanglement, it might become possible not only to exchange information instantly, but even to travel by passing through these quantum bridges. When we think about space-time, it feels to us like something fundamental, something existing independently of us. But what if space arises from the interactions of particles, from their invisible connections? This is not just a bold hypothesis, but one of the most exciting breakthroughs in theoretical physics. Scientists are increasingly inclined to believe that space-time is not primary, but a result of the quantum. Entanglement creates space. Experiments confirm this. Imagine a complex labyrinth where paths emerge when there is a connection between 2 points. Something similar might be happening in the universe. When particles entangle, it is as if bridges are built between them. It is these connections that form space. So how can this be verified? Surprisingly, experiments have already given the first clues. In 2015, a group of physicists from the University of California showed that entanglement does not simply connect particles to each other, but could also be related to the geometry of space. They examined small fluctuations in the vacuum and discovered that the degree of quantum entanglement affects the curvature of spacetime. In other words, by changing the entanglement, you can change space itself. If entanglement brings space into existence, then this question arises. Which came first? If entanglement is removed, does space also disappear? Some theorists suggest that reality is based not on matter or energy, but on pure information. Physicist Leonard Susskind and his colleagues developed the concept of tensor networks, which are mathematical structures that can explain how quantum information is intertwined in complex systems. These networks resemble the structure of space-time in a striking way. This suggests that space is just a side effect of information interactions. If so, the universe is not just a world of particles, but a large computational system where entanglement plays the role of a program controlling the structure of reality. However, if space is a dynamic thing stemming from quantum information, theoretically we can learn to control it. Perhaps in a distant future, humanity will be able to create artificial wormholes. If space arises with entanglement, it can be constructed. We can also change the geometry of space. Imagine technologies that can form new ways of movement by bending space as in science fiction, and finally understand the essence of gravity. If gravity truly emerges as an effect of entanglement, this could overturn all of physics. So what does this mean for us right now? This means that reality is much more flexible than we thought. We do not live in a static world. We live in a quantum network where entanglement forms the fabric of reality. Yes, it all sounds like science fiction, but reality might be structured in this way. Actually, black holes are not just mysterious monsters of the universe. Both gravity and quantum mechanics manifest themselves in black holes. And if space-time truly arises from entanglement, then black holes must become the main test area of this hypothesis. When something falls into a black hole, it seems as if it is lost forever. However, this is not entirely true. Physicists discovered that information about lost objects is not destroyed, but remains encoded on the event horizon, the thin boundary separating the black hole from the rest of the world. And here a paradox arises. If black holes truly store information in the form of quantum entanglement, their surfaces can be seen as a giant hologram reflecting everything that falls inside. Does this mean that the black hole is not just a gravity trap, but a window opening to the fundamental nature of reality? Physicist Juan Maldacena put forward a revolutionary hypothesis. Perhaps all our space is a giant hologram, and true reality exists as quantum information encoded at the distant end of the universe. Black holes play an important role here. Their behavior is exactly the same as the behavior of quantum systems. This means that space-time is also likely structured in the same way. In other words, space-time is quantum entanglement, and black holes are holes in this quantum fabric. One of the most exciting studies of recent years is related to the soft hair of black holes. In 2016, Stephen Hawking suggested that traces of information about absorbed objects remain on the event horizon. In 2022, physicists found the first mathematical evidence that this information is indeed recorded in its structure. And in 2023, scientists performed an experiment on a quantum computer and simulated the behavior of entangled particles in conditions similar to the gravity effects of black holes. The results were striking. Entanglement indeed behaved as if it were shaping the geometry of space inside the black hole. But black holes might be hiding more. If the theory is true, its meaning is this. Space is something that can be created or destroyed by changing the entanglement. Inside black holes, there might be a brand new physics that we do not yet understand. And finally, wormholes could be real. Black holes are not the end of the road, but the beginning. They are a window opening to quantum reality where space-time is born, transformed, and disappears by obeying the laws of entanglement. We started this journey with a simple but striking idea. Space and time are not fundamental features of reality, but a result of quantum entanglement. And now, step by step, we see that this is not just a beautiful hypothesis, but a theory supported by mathematics, unexpected experiments, and even the behaviors of black holes. Let's summarize the most important discoveries. Space-time is not the basis of reality, but a derivative of quantum information. Entanglement is the building material of the universe. Quantum connections create the concept of distance. The ER equals EPR theory shows that gravity and quantum mechanics are related to each other. Wormholes and entanglement are the same thing. Black holes behave as if space were a hologram. Event horizons might be quantum mirrors of all information. Modern experiments are already confirming some of these ideas. If space-time truly stems from quantum entanglement, then gravity will cease to be a force and become a side effect of quantum processes. It will be possible to create artificial space and even perhaps change the fabric of reality. Wormholes connecting the distant corners of the universe might not be science fiction, but a real possibility. And most interestingly, our perception of the world might be limited by this space-time illusion, and something larger might lie beyond its boundaries. It turns out that space and time are just ghosts in the infinite game of quantum information. So what is the real reality?